Today's presentation, I'll be presenting on managing chemical exposures. This is something that is probably more my forte, given my education and background in industrial hygiene. We spend less time on this in local government agencies than maybe some of the industries that I've worked in because of the type of work we do, but it's no less important. We have some really nasty stuff that some of our folks in local government agencies are working with on a regular basis. And we need to look at those exposures and ensure that we're keeping our people safe, as well as meeting our compliance obligations that we have. And that's really what this presentation is about today. We've spent a lot of time in the last year worrying about a certain virus. And whether we're exposed to that. Well, I'm here to tell you that we have some chemical agents that we're working with in your facilities, many of your facilities, that I'm far more concerned with than I am a coronavirus, because they're more immediate and serious hazards. And so things like chlorine gas or things like that can be real serious hazards. So we got to take those for what they are, a hazard to our people, and manage those accordingly. So I've got a lot of material in here, so I'm gonna burn through some of it, so we make sure that we've got time for questions and all of that, and realize that I'm not going to go into great detail on some of the specific chemical agents that we'll talk about, but I do have webinars on each of those. I think so. Now I said that, I may have one that I don't have a webinar on, but I do have materials on the vast majority of everything we'll talk about that go into greater detail, whether it's respiratory protection or silica or any of those things. And also, that's what we're here for. Our job is to help you. If you've got questions, got concerns, we're here to help you out on that. So there are chemicals everywhere. You know what? Chemicals in my drink. I put a little bit of lemonade in with my water today. Guess what? There are chemicals in there. Is it going to kill me? Well, I guess it depends on how much I drink. But we all deal with chemicals. Is there something under your kitchen sink that will kill you? Probably. Is there something in your bathroom, if you mix those things together that are under your bathroom sink, that can kill you? Probably. And so we need to realize that the hazard is universal, but it can be significantly worse depending on the type of work that we're doing. Some of those chemicals are really nasty. Like I said, chlorine gas. Fluoride. In some of our counties, we have a requirement to put fluoride into our water. Well, that's something that we drink in really low concentrations, and it's good for our teeth. But as we're dealing with that chemical, hydrofluorosilicic acid, I believe, is what most of those water districts or municipalities are using, is highly toxic. And if you splash that stuff on you, it is really bad for your health. So there are things that we work with that are serious. Things like bleach, we may not think a lot about, but it can be really risky. Acids and bases and water treatment chemicals, the normal confined space chemicals that we look at on our 4-gas meter, the carbon monoxide and hydrogen sulfide, those types of things. But some things we may not consider. If we're welding on stainless steel, we're being exposed to hexavalent chromium. If we're welding or cutting galvanized steel, then we're going to be dealing with manganese and zinc that can cause a really acute syndrome called metal fume fever. And if you've ever cut galvanized steel or welded it without respiratory protection or good ventilation, you'll know what I'm talking about. You feel like you've got the flu and are sick as a dog. But there are also long-term issues, chronic issues with that type of exposure that we really don't want to deal with. And so that's what we're talking about today, are these things that we deal with. Oh, one of the, I look on their pesticides. How many pesticides do we apply, whether it's in mosquito abatement or just our simple grounds maintenance chemicals that we're using, 2,4-D and other pesticides like that. These all have potential issues for our health and the health of our workers. I wanted to go through. I thought it was actually on a different slide. There we go. I'm catching up just a little bit. Here's some of the things that we're going to go through today. I won't spend much time on the overview slide, but let's talk about things so we understand when we're talking chemical exposure, the state of matter that chemical or material is in is important. Solids, liquids, gases, or plasma. We won't talk about plasma today. That's a high energy state, and generally we don't deal with that. Can something in a solid state be hazardous to me? The answer is absolutely. Asbestos is in a solid state, and if I breathe those fibers into my lungs, they can cause me long-term health issues and really result in my death. Liquids and gases, both ways, are hazardous chemicals to us, can be. Okay. And I wanted to get over one important point about this. Whether it's solids, liquids, or gases, the smaller the particle, the greater the hazard. That is a standard rule that we have. What do I mean by that? Well, I may have some dust that is in big particles. And what does that particle do? When I breathe it in, our bodies have a great system to be able to filter out bad stuff if it's big. So if I'm breathing in dust and I breathe it in through my nose into my sinus passages, there are all these little passages that go around in there. There's hair, there's mucus, there's all kinds of, sorry, you're getting grossed out just thinking about my nose. All this stuff is in each one of our noses. And the idea of our sinus passages there is it traps big particles. And then when you get done sweeping up the shop and you blow your nose and you look down at that tissue, you go, ooh, yuck. Well, instead of saying yuck, say hallelujah. My respiratory system is working to filter out those big particles. Problem is, the smaller the particles, the less effective our respiratory system is on filtering it out. If those small particles get into the deep reaches of my lungs, and like I said, it could be a gas, or it could be a solid particle or a liquid particle. Gases are not particles. They can just go where they want. If they get into the deep reaches of my lungs, they can have serious effects on my body because they hit my bloodstream and they can go anywhere in my body and do damage. And so that's what we're looking at. So the smaller the particle, the greater the hazard. Now, I want to give you just one more quick example on that. The difference between a dust and a fume. A dust is thought of as a big particle. A fume is a really small solid particle. So a lot of times on the news, they talk about gas fumes coming out of your gas tank when you pump gas. That's inaccurate. Those are vapors that are coming out of your gas tank because it's a gas coming off of a liquid as it evaporates. As we talk about a fume, it is a really, really small solid particle. So if you're welding, if you've ever welded, the purpose of welding is we put a whole bunch of heat energy, electrical energy on that metal to cause it to become a liquid and fuse together. Some of that metal gets so hot that it vaporizes for just a split second as it comes away from the arc of our welder, and as it comes away, it cools down and it condenses into a really small solid particle called a fume. Acids can also release fumes as well. Well, the really bad part about this is it can get past a lot of things. Even, with the example of welding fumes, as we've looked at respiratory protection over the last year, we look at these surgical masks and all of those things, and then we bump up to an N95 mask. Well, in this example, an N95 ain't good enough. I've got to go to a much higher level of protection for those fumes because of the size of the particles. They can get around an N95 mask. Okay, so the smaller the particle, the greater the hazard. How do chemicals get into our bodies? Well, there are really four main routes: inhalation, ingestion, absorption, and injection. And the inhalation route through our lungs or respiratory system is the primary route we're worried about. Now, the rest of them are all important. Injection could be like a leaky hydraulic line injecting oil into your system. Absorption through your skin. Our skin's a barrier to some chemicals, but not all. Some chemicals will go right through our skin and into our body. Ingestion, most of the time that we don't intentionally go out and say, "Ooh, hey, what's this in this bottle that looks like a nasty chemical?" and take a drink. Most of the time, ingestion route of exposure happens accidentally. We don't wash our hands after we're using a certain product, and then we go eat lunch. We don't use proper PPE. It gets on surfaces and we touch the surface and we unintentionally eat or drink this material. It's not as much ingestion, but smoking is a great way to get really nasty stuff in your body. How do you do that? Well, I have some chemical agent on my hands and I touch a cigarette and smoke, that directly sends it right into my respiratory system. But inhalation is the primary route. We're worried about it because if it gets in my lungs, it gets to my bloodstream and it can go anywhere it wants from that point. Just a couple of quick things. What's the difference between acute and chronic effects? This is really how long after your exposure to the chemical when you see the effect. And a given chemical can have an acute and a chronic effect. Quick example of that would be sulfuric acid. If I spill battery acid, which sulfuric acid is, I spill that on my hand, I'm going to say, ow, 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 and run to the sink right now and wash that stuff off and wash to try to get rid of that because it's corrosive. It has an acute effect. Sulfuric acid also has a chronic effect. If I work in a bumper plating shop for my entire career, I spend 30 years in there breathing even lower levels of sulfuric acid, there is a risk that I get lung cancer from exposure to sulfuric acid. So that's something I have to keep in mind, is just because I got away with this today, I worked with this stuff and I don't feel sick, I'm not coughing, it's not burning, there's nothing like that. That doesn't mean it hasn't got me. There are things like asbestos that may take 20 to 30 years after exposure before I realize it got me. And all of a sudden I go into the doctor and I've got lung cancer, I've got mesothelioma or something like that. And I have to go back in history 20 or 30 years when I did a job working in, tearing down an old building or whatever it was that you did. That is a chronic effect that can be really tragic. So we've got to understand what those are for each of the chemicals that we deal with. Where can you get that kind of information? Well, your safety data sheet has a ton of that information. All right, I want to hit just a couple other things in managing these chemical exposures. Exposure limits. We've got to know how much we can be exposed to. How much is too much? And there are kind of two different angles on these exposure limits. Some are legal limits and some are best practices. Some are based on current science and some are based on politics. So just to continue on that line, we have the permissible exposure limit, or PEL. That's OSHA's number. And that's what you can, if you overexpose one of your employees to above the PEL, you can get a citation from OSHA. It doesn't necessarily mean that is a safe limit for the employee's health. Just an example of that, there are chemicals like anhydrous ammonia, where anhydrous's PEL is 50, whereas the other number I'm going to talk about, the threshold limit value, is 25. It's fully half what the exposure limit is that you can legally be cited for. So the threshold limit value, in my opinion, is the best number that we have. It is updated every year. They put out a notice of new changes. And then there are changes that happen. They take the best science that we have from exposure studies and unfortunately sometimes from accidents where we see what happens to people when they're exposed at different levels. There's animal studies and all of those things that go in. The TLV is the number that I would base my health decisions on. From a compliance standpoint, I need to know what the PEL is, because if I overexpose somebody, then I can be cited for exposing that employee beyond what is legally required. Now, these limits are what we call time-weighted averages. So if you go into work and obviously your exposure is going to go up and down. I come into work, I'm working in the office for a couple of hours, and then something goes absolutely haywire out in the let's make it not make it chlorine. I don't know. Anhydrous ammonia I talked about. Let's say I get an exposure to 100 parts per million for 4 hours. And then I go back and I work in the office for the last 2 hours a day with 0 exposure. So through that day, I've had 4 hours of 100 parts per million and 4 hours of 0. If I average that out, my exposure is 50 parts per million. And guess what? I just broke OSHA's PEL, and my employer could be cited for that overexposure. Okay, so they can go up and down, but it's the average over that time limit. Now, there are a few chemicals that have a ceiling limit, and that's one that you may be dealing with, chlorine gas. And it has a ceiling limit of 1 part per million. That's a really, really low concentration. So if I'm working there, I can't have that up and down. I can't go up to 10 because I'm only going to be exposed here for 3 minutes. Or for a half hour. I have to keep my exposures under 1 part per million. Well, what if I go over? I have to have appropriate respiratory protection. And that's something that we'll talk about as well, is when I get in that point where I'm overexposed, I have to provide respiratory protection after I've done everything I can to engineer out to eliminate that hazard or reduce that hazard. Okay. All right, I'm going to go on. So here's just some examples. Chlorine gas, the 1 part per million ceiling limit. Carbon monoxide, 10 parts per million. Asbestos. I think I actually may have messed up on that carbon monoxide. Doug, can you look up that? I think I messed up on the PEL for carbon monoxide. That's actually where your confined space meter is going to alarm at. So I apologize for that one. Asbestos is 1/10 of a fiber per cubic centimeter of air. Lead, 50 micrograms per cubic meter. Why am I talking about all this stuff? Well, to point out, you can see that we have various different measurements here. 1 part or a part per million is just what it sounds like. I take a box of air and I divide it up into 1 million little boxes, and I put 1 little box of chlorine in there. That's 1 part per million. These, where I'm talking about micrograms per cubic meter or milligrams per cubic meter, that's a weight. So if I've got a solid or a liquid that is up in the air, I'm looking at the mass of that per unit volume, which is cubic meter is the standard that we use on that. So
Jason, so the PEL on carbon monoxide is 50.
50. I just wanted to make sure. I knew it was 50, but I wanted to verify just so I didn't steer people wrong there. So that 10 parts per million that I have there is the alarm level on your confined space meter. All right, thanks, Doug. Appreciate that. So we have to understand what those units are, and I can't just compare one to another without knowing what that means. Can I go back and forth between milligrams per cubic meter and parts per million? You can, and there's a neat calculation. If you're interested in it, that would be a great conversation I'd love to have with you. Why do I bring this up? I got to know how much is too much. So how do I know? I have to test. I can't just go out there and say, well, I can't see any in the air. That actually used to be what they did with dust. It was an opacity thing. They'd say, well, if you can't see this far, then you're at this level. Don't do that, because a lot of times the stuff that we're dealing with is invisible. We can't smell it, we can't taste it. We have to do gas detection. We have to see what those exposure levels are. So who, what, where, how, why, all of those things, gas detection. It's a challenge, and sometimes we need to bring an expert in, and we can help on those things as well. If you've got a challenge there and you don't understand that, how to look at it. We also can do some limited sampling as well. But it's something that we want to really be open and look at this and say, what really are we dealing with when it comes to chemicals? If we're not, if it's clear that we're not releasing chemicals, we probably don't have to do sampling there. But if we're using a specific chemical, and particularly if it has low concentrations, we need to do sampling for that. Sometimes it's really easy. So sometimes we can have a confined space meter, and it will tell me my carbon monoxide level. So am I over 50 parts per million? Of carbon monoxide? I pull out this direct reading meter and I can tell you. I got to make sure it's bump tested, and I got to make sure it's calibrated so it reads right. The challenge is your 4-gas meter reads 4 gases. It reads your oxygen, your percent of your lower explosive limit, carbon monoxide, and hydrogen sulfide, and that's it. If I have silica or chlorine or lead or whatever, I've got to use another method to sample for that. And that's where it gets technical, and that's where you may need to bring in an expert to help with that. And generally, an industrial hygienist is the job title, or the person that you'd want to bring in for that. But we look at things like silica. Maybe I'm exposed. I've got guys out cutting concrete. This is the type of sampling apparatus that we would use. It's called a cyclone. And we have a little filter in there in a cassette, and we calibrate it, and we have to calculate how much air goes through there, and then we send it off to a lab, and they give me a number that tells me what that exposure is. This is not a direct reading. It's something that takes time to do that. So as I'm talking about managing chemical exposures, if you find yourself in this area where, wow, we really have something we need to evaluate, let's talk. Give me a call, and let's talk through that and come up with a plan on how we can make that work. So managing exposure, we got to look at compliance. That's part of it. Now, I always want to make sure that I am not overexposing anybody that I'm supervising, right? Any of my staff, that's the minimum level, right? We've got to verify that we're complying. Beyond that, I would try to base all of my decisions on the threshold limit value, the TLV, because that's going to be the healthiest for my staff and for anybody there. So those are some basic things. Other compliance things, we need to build a plan around this. There are specific requirements for certain chemicals. If you're dealing with asbestos or lead, or silica, there are specific requirements for that, and I should build a chemical specific plan for that says this is how we're going to handle dealing with these chemicals and the types of controls and personal protective equipment that we're going to put in place. Okay. All right. So under compliance, there are a few different areas I want to talk about. One is hazard communication. Most of us are really familiar with this, and I have a webinar on the YouTube channel going over the hazard communication plan, or the standard from OSHA. This is an OSHA requirement, and it's basically I hear a lot of people saying hazardous communication. That hazardous communication is if I'm poking you in the eyes while we're talking. This is hazard communication. I'm trying to tell you, to get across to you the hazard of chemicals. And so with hazard communication, and I'll go into detail on that, or a little bit of detail there, but realize there's a full webinar on that. Chemical hygiene plan. This is if you have a lab So I have a laboratory, and some of our water districts out there, wastewater districts, may have a specific lab and may fall under the OSHA requirements for a chemical hygiene plan. That's another big one. I'm not going to go into any detail on that today, but because it's fairly rare out there. But if you do find yourself questioning, well, we have a lab, let's have a chat and talk about that. Just a couple other compliance things. If you are abating asbestos, lead paint, those types of things, there are certifications that you have to get through the state. The Department of Environmental Quality manages those. And you may say, well, we're not going out and doing abatement. Think carefully on that. Some municipalities, water districts may have asbestos pipe, the old transite pipe that's there. And if I'm doing abatement on that, I'm pulling that stuff out and replacing it, I probably fall into a requirement to have those certifications. Now, can I do it? Can I just hire a contractor? And the answer is yes. But if that's the case, your staff shouldn't be participating. And then, like I said, there are various standards that are specific to different chemical agents. Some of these definitely apply to local government agencies, silica being one, asbestos and lead maybe, depending on what you have there. Hexavalent chromium is, if we're welding on, this is the most common area that I would see that, if we're welding on stainless steel. In the type of work that I see most of you doing out there in local government agencies, if we're welding stainless steel, we could potentially trip that hexavalent chromium standard. I won't go into detail on that, but if you've got that, let me know. So hazard communication, this basically says that I have to have a written hazard communication program. I got to have a list written of all the chemicals. So what does that mean? I have to go out to the public works shop and look at that whole wall of all the stuff that they have there? And the answer is yes. I have to look at all that stuff, and I have to develop a list of what those chemicals are. And then I have to get a safety data sheet for every one of those. What does that do after you go out to the shop the first time? Well, that makes us control our purchasing a little better. Purchase the same materials over and over again, the same products, and don't just go out and buy what's on sale, because then I got to go through and put it on my list, and I've got to get an SDS sheet for it and all of those things. Employees need to be trained on the hazard, and they need to know where to get information about the hazards. Where are the SDS sheets? Where's the list of chemicals? What are the labels that I'm working with? That's another thing. We have to have a labeling system that everybody can understand. If I'm just using the manufacturer's labels, that's cool. That's great. But anytime I take that material out of the manufacturer's container and put it into a spray bottle, because it comes in bulk, and I put it in a spray bottle to be able to use that, then I have to have a labeling system that the employees understand. Okay. And once again, there's a whole video on this. Provide SDS sheets and have those in an available area where your employees can find those. And we got to keep them up to date. If something changes, the manufacturer of a chemical sends out a new SDS sheet, I've got to update. And just from a compliance standpoint, I got to keep all those old ones. How long do I have to keep all of those SDS sheets if I'm not using that product anymore? The answer is 30 years after the last employee used that. So you probably want to get a scanning system together so I can keep track of all of those for perpetuity, because basically they'll be around longer than you will. Okay. All right, we talked about labeling. So employees need to be trained on where to locate those SDS sheets, what the HAZCOM program is that you have, how to handle and store chemicals, labeling, and where to get different sources of information. Okay. All right, I want to talk about protecting workers now. We've covered that basic compliance side of things. We have a hierarchy of controls, and really we want to eliminate the exposure if we possibly can. So as we go out and do risk assessments to your facility, sometimes we'll find a abrasive blast cabinet, silica sandblast cabinet. And I'll ask questions about, okay, do you have silica in there? Why? Well, there's a whole different regulatory level, and it's a lot riskier than other things that we can use. And generally, I'll give a recommendation right there. Hey, if you're not using it, get rid of it. If you're using it and you're using silica sand, why don't we look for a different option than silica? Because that stuff gets in your lungs and it can cause silicosis and it can literally kill your people. So why don't we go to a different abrasive material? And they have all different types that will do a lot of different things for us, and they're not nearly as hazardous. So elimination should be the number one. If I don't have to use this stuff, don't use it. Engineering controls should happen next. I'm going to use, so in this picture, we see they're cutting concrete. Well, what's an engineering control that we use there? It would be wet cutting. So if I flood this blade and I flood the cutting area with water, the chances that I get dust up in the air go way down. That's an engineering control. Ventilation is an engineering control. So that's the next thing. If I can't get rid of it, let's engineer it out. Beyond that, we can do an administrative control, which means I'm going to limit the exposure by limiting the time or changing how this works, how people are exposed. I may have a bad job, and I don't recommend doing this, but it is an option. This is a bad job, so I'm going to have everybody go in there for 10 minutes, and they're going to do the job, and then the next person's going to go in, and they're going to do that job for 10 minutes. That's not great, but it's definitely better than putting that one person in there for 8-hour stretch doing this high exposure job. The last line of defense, but really important line of defense, is personal protective equipment. How do I keep people safe? Remembering that this is the last line of defense. It's just a little barrier, piece of plastic or a filter or whatever it may be between you and something that can hurt you. Well, I wanted to talk, let me jump back there. This should be our program. We should look at this and we should prioritize these things and figure out how we minimize this. Does that mean PPE is not used? No, it's part of our program, but it should be that last choice that we make. All right, I want to, I don't know, Doug, if we have any questions or anything like that. Oh, I'm looking, I'm seeing some chats there.
Yeah, no questions, Jason.
All right. I want to talk about some of those specific agents that are there, and I'm going to burn through these pretty quickly. But because some of you may have this, we definitely want to make sure that you're aware of the risks and that you take appropriate action. So asbestos, lead, silica are ones that I'm going to go through these standards because they're specific and they're ones that we can deal with where we work. So asbestos is an awesome material. It is something that doesn't burn. We can incorporate it into materials that makes things fire resistant. It will take high heat. This is a really cool mineral. It's something that is mined out of the ground, and it does awesome stuff. The only problem is it can kill us. And so really from the Industrial Revolution until the late 70s, we put this stuff in about everything. We'd even put it in the flocking that they would put on Christmas trees to make your trees really pretty because it was fibrous and it wouldn't burn and all of those things. Problem is, if I breathe this stuff in, it can cause asbestosis, lung cancer, mesothelioma, bad stuff. Well, we got rid of all of it now, right? Well, not really. It is not actively produced in products now, except a few limited products where they don't have an option. It's something they really need to use, but it may exist in our buildings. If we have a building that's older than the mid 1980s, what I would say, there's a good chance that there's asbestos in our buildings. If I have concrete pipe, water lines, sewer lines that are in the ground that are older, there is a fair chance that it is asbestos containing concrete. And so if I go out there with a saw and start cutting into that, I can get a big dose of asbestos. It's things like floor tiles, the old 9x9 floor tiles. If you think of 50s floor tiles, that those are generally containing asbestos. Well, you may have those in your basement. I do. I have some of those. I have an older house, and should I be really worried about that? Well, it depends on how. If I'm going down with a buffer all the time on those floor tiles, and I'm not using wet methods or anything like that, that could be a problem. In my basement, I've got all but one section tiled over. I encapsulated that asbestos tile with additional tile. I just put it right over top, so I wouldn't get those fibers up in the air. All right, we'll keep going here because I got to go quick. Anyway, asbestos is in a ton of different things: pipe insulation, and brake linings, acoustical tiles, plaster, the old popcorn ceilings that we'd have on the roof. Many of those have asbestos in those. And so we've got to be aware that it could be in our buildings, particularly if they're older buildings. It causes these nasty diseases: asbestosis, lung cancer, various different types of cancers. Here's an example of that, asbestos pipe. But if I'm looking in a mechanical room, I'm looking in, real physical parts of my building, and it's an older building, there's a fair chance that asbestos is there. I can't just look at it and say that, yeah, that has asbestos or it doesn't. We really have to do a test on that to see if it's asbestos containing material. So preventing asbestos exposure, the best thing is to leave this stuff be unless it is damaged. If it's friable, if it's stuff that can break apart and get up in the air, then I definitely want to deal with that. But if it's in good shape, my tiles in my basement that are still in good shape, they're okay to stay there. I might if I ever get my job done and finish tiling that section of my basement, then it is contained, and that's even better. If I've got something that I've identified as asbestos, I want to mark it so we don't have our maintenance guy go out there and start pulling insulation off of the pipes and inadvertently expose himself. Okay. All right. So in controlling, I can remove, enclose, or encapsulate. If you're doing any of those things, I would bring in an outside contractor. We can talk about your specifics there, but just don't have somebody go in and start tearing apart the old boiler system that we have that has pipe insulation all over it. We've got to address that. Most of our facilities, we've probably done a review on that. Let's see, I covered that. I got to go quick. Put signs up if we do identify it. Once again, so this is some of that asbestos tile. You can see how it's peeling up there. Well, this is something I've got to deal with. But I would hire a contractor who is certified to be able to do that, to come in and take that stuff out. Unless it's a situation where I can just tile over it. If that will work, you can do that. Problem is where I have these rough edges. And there's some best practices here that you can go back and look at the video on this as far as dealing if you have those tiles in the workplace. But I'm getting down on time, so I'm going to go quickly. Lead is another one that's there, and generally the exposure that you'll find with lead is with lead paint. There could be some situations with cast iron pipes where they've used lead to seal things up. I'm trying to think of some electronics would be some other industries where we would see it. But lead is some nasty stuff as well. And once again, this is back in the late 70s. We stopped using most of this, but we still use lead paint in certain, if they're painting, and I don't send the fact checkers after me, but this is just an example. I've got the Golden Gate Bridge. That's a pretty rough environment. They probably still use lead paint on the Golden Gate Bridge because of the type of environment that it's exposed to. But most of our homes, if they're built you know, past the 80s it will not have that. But if I've got an older home, there's a fair chance that I have lead paint there. Our old buildings that we have around. And if I dive into that and start sanding and chipping and grinding on that paint, I can get a serious exposure. What's the big problem with lead? It sticks with us just the same as asbestos, but in a different way. Lead stays in my body a long, long time. It's fat soluble and it can stay there and cause issues. And so I've got to handle lead differently than I would other things that pass through my body fairly quickly. Back in the 70s, we took the lead out of gasoline. Before that, we had significant lead exposures with people just breathing automobile exhaust. But sometimes recreational things, like we talked in the hearing conservation webinar earlier today, like shooting. If I shoot inside of an indoor range, if I don't have good ventilation, I can get lead exposures. If I'm melting lead to make sinkers for fishing, I can get lead exposures there. Causes some serious, we talk about lead poisoning, but it can affect our brain, nervous system, our gastrointestinal system, and it's worse in kids. If I put sinkers in my mouth while I'm fishing and I swallowed those, they would probably pass through my system without causing me a lot of trouble. But a small child has a lot more ability to uptake that lead. And so if they're picking paint off the walls in your old house and eating those paint chips, that can be really serious to kids. And so that's why we really worry about lead paint in houses. Okay. These are long-lasting effects. They can be fatal. There's some symptoms that we have there. Whoops, click the button twice. All right. Metalwork, solder contains lead. If you live in Flint, Michigan, your water contains lead. That was a tragedy that happened there, and it was a simple thing. They got a different water source in that had a low pH, and it leached lead out of the pipes, the metal pipes that carried water to the homes in Flint, Michigan. And to this day, they still have lead issues there. And as far as I know, they're still bringing in water to many of the people in Flint, Michigan, because they can't get the lead levels down low enough. Okay. All right, so there is a specific standard for lead as well as asbestos under OSHA. There is an action level. If you're exposed at this level, then you have, and that means if people are doing this kind of work, I'm going to be doing sampling. I'm going to be doing air sampling to tell what that exposure level is. So if I breach the action level, then I need to put a lead program in place, and that involves both air monitoring, PPE, engineering controls, all of those things, and blood lead monitoring. What do you mean by that? That means if you're working in a lead industry, you actually have to get blood tests periodically to ensure that you're not being overexposed. And if you are overexposed, then you have to be medically removed, basically pull you out of that job and put you in something else. I'm going to wrap this up right away, but here's an example. I had a situation where we were using lead with a former employer, and we did air sampling. Air samples were all really good. And then one day we had an employee come up with a high blood lead level. Holy cow, what's going on there? I wonder if it's a bad sample or what's up. And so we went right out and just kind of stood back for a little bit and observed this employee. And what we found was this guy didn't have very good hygiene practices. He wasn't using his PPE the way he was supposed to, and he really liked to smoke. So he would work with the product and get lead on his hand. And when the brake bell would ring, he would run outside and smoke. And the guy really liked to smoke, and he would get 2 or 3 cigarettes done in a short period of time, and then go back to work, and he wouldn't wash his hands. And the same thing happened at lunch. Should have been wearing gloves, wasn't following that part of the program either. So we pulled him out, medically removed him from the job, worked with him to over time to get his blood lead level down, and worked on his hygiene practices and compliance with our PPE requirements to keep him safe. All right, I'm going to hit, if you find lead paint, mark the stuff, you know, and train your facilities people so they understand. Don't go out and start grinding on this. Don't go out and start scraping on this lead paint. And if we're going to do a major renovation there, we should probably bring in a contractor to do this. Or if you really want to do it, you're going to have to get the certifications and do all the things. And it's in the long run, it's probably better just to bring a contractor in. I want to hit silica just briefly. This is probably one of the more common ones that we have. If you're cutting concrete, grinding concrete, dealing with masonry, those types of things, this is bad stuff. It gets in your lungs and causes silicosis, and it can be fatal for people. The other things would be like sandblasting as well. So it's crystalline silica. And it's a lot of different jobs that are there. There is an OSHA standard on this, and it's designed to prevent silicosis, cancer, kidney issues, all of these things that can happen with that. I'm gonna, and just on that one, sometimes some people can get silicosis in months. Some can work with this for decades, and then all of a sudden it's got them. Couple of things on this. So OSHA has, they updated their standard. If you go into our YouTube channel, I have a whole detailed webinar on this. But I just want to cover that the exposure limit went way down, and it is really low. And they required all of these things. Due to time, I'm not going to go through that. This is an example though, how much crystalline silica in a room 10 by 10 by 7, just a little bigger than, or a little smaller than my office here, to make 50 micrograms per cubic meter. That's the PEL. Well, this is a dime, and that's how much crystalline silica it would take in a room that size up in the air to exceed that standard. So it's really low. If you can see dust out on with your guys doing these jobs, they're too high. And so OSHA has developed fact sheets on various different things. If I'm operating a rotary hammer or a concrete saw or something like that, there is a fact sheet on that tells exactly what you need to do to reduce those exposures. And that may be buying a new saw that has a water attachment. It may be buying a new grinder that has ventilation attached to it, et cetera, and a HEPA vac that deals with that. Well, some of these are really over the top standards. You may be involved with that, or you may not. You may have simple chemical exposures in your workplace. Either way, they're all important, and they're things that we should be that we're legally and ethically obligated to help our staff understand the risks to them and provide them a safe workplace. And so with that, know what you're getting into. Look around and say, what are we doing out there? Do we have any of these nasties? If not, what are we dealing with, and are we doing as good a job as we can? Let's put engineering controls in. Let's eliminate the material if we can. If I've got to use PPE, let's use the right stuff for the job. Once again, I've got a respiratory protection video that's out on YouTube there that can help you in determining the appropriate respiratory protection. But I would love to help out. If you have questions about that, give me a call and I can help out on that. Monitor exposures, train your people, and let's keep them safe out there. Ooh, I went a little long, Doug. I knew that was going to be the case. Folks, if you've got any questions, type those into the chat box, and or any comments, I'll be happy to answer those. Sorry, Doug.
That's okay, Jason. I don't see any questions yet.
Okay. That was a lot of material that we covered there, and I understand. Sorry for just how much is there, but it's a big subject. And if we go into each one of those different agents that are there, it's a big deal. So I'm happy to have that conversation with anybody out there that that wants to discuss it.
We have some thank yous coming in.
Well, I like those. They hung around for 52 minutes, so so that's good. All right. Well, should we wrap it up with that?
Let's do it. Last words, Jason.
Last words. Know what you're getting into. Be safe out there. Pay attention to these things. I'm gonna say here, this is one thing that's bugged me a little bit. We've got these masks, these surgical masks that we're using for COVID. That is not respiratory protection. I do want to end just on that. That is not respiratory protection. Realize that an N95 mask takes out maybe 95% of the stuff that we're dealing with. I watch DIY stuff on YouTube, people doing different projects, and they're wearing these things for stuff like cutting concrete and doing dealing with some of these nasty things. Let's protect our people. Don't think that something like this is going to protect you from that really nasty stuff that's out there. Let's build a program around this and come up with an effective program. That's what we're here for at the Trust. That's our job, is to help you keep your people safe. And everybody go out and have a safe day.